Yeah. Yeah, good afternoon everyone. So let me continue the friction. See what I covered in the last one. So I hope I covered just the basics related to the friction. We know the meaning of friction. And tell me how many types of frictions? How many types of frictions? Three types. Static friction, kinetic friction, and rolling friction. And of course, we know some advantages of friction and very few advantages also. We know that. And every frictional force proportional to normal reaction force. Every frictional force proportional to normal reaction force. Okay, we got mu s, mu k, mu r. What are mu s, mu k, mu r? Coefficient of static friction, coefficient of kinetic friction, and coefficient of rolling friction. Okay. Anyhow, we know the relation between three frictions are Fs greater than Fk greater than Fr. Okay, this we covered in the last step. And written mu s greater than mu k greater than mu r. Okay, up to here I covered in the last session. Okay, now let me continue some basic level of problems and next concept. Okay, before that, let us see. We know already if a block is placed on horizontal surface, then we know normal reaction force is balanced by weight of the block. For suppose there is a block whose mass is m, block of mass m, which is placed on horizontal surface. Then we know normal reaction will act perpendicular to the contact surface. This is balanced by what? Mg. So what is n here? N is balanced by mg. For suppose they given two blocks, they place one over the other. Let us see how to get the normal reaction. Okay, if you are comfortable with the free body diagram concept, FBD, from laws of motion, from Newton laws. If you are comfortable with the Newton laws, comfortable with the free body diagram concept, then we can find two blocks, three blocks, number of blocks also we can find. Let us see for two blocks. So let me draw here. So let me find what is N1 and N2. Here one block is placed whose mass is something M1. Another block placed above this, mass is M2. Here there are two normal reactions. If it is one block, one normal reaction. For two blocks, two normal reaction. For three you will get. Yeah. Here, in this contact surface, there will be a normal reaction. Let us call it as something N1. And here, N2. And I told you already in the last class, normal reaction force is what? Is it a contact force or not? Remember?
Contact.
Yeah, it is what? Contact force. Contact force nothing but it is a pair of forces. And that pair of forces will act on same body or different body?
Different body.
Yeah, definitely on different body. If you feel about only M1, on M1, just you listen my words carefully. On M1, N1 act up or down? On M1, N1 act. N1 act upward. Is it clear? Normal reaction is, see, in which side it is acting? Upward. Normal reaction on M1 acting upward. And this normal reaction is a contact force and pair of force. Definitely N1 act on ground. Is it clear? Because it is action and reaction force. If I am standing on a floor, N1 on me up, N1 on floor down. If one is the action, other one is the reaction. And you follow this N1, direction of N1 you followed.
Yes, sir.
Respond it now. Direction of N1 is clear?
Yes, sir.
Yeah.
Yes, sir.
Then you think about N2. N2 means, yeah? Tell me. Coming to the N2. N2 starts from here. N2 starts from here. On M2 it is acting. This is what?
Action force.
Yeah, action force. Tell me, one more reaction is on where? Is it on M2 or M1?
On M1.
Very good. This is M1 body. Are you follow the directions? If it is 3, you continue the same process. Follow the directions. N2 on M2 is up. And on M1, see, we can use the words like this. N2 is what? Force exerted by this. See my hand. N2 is the force exerted by M2 on M1. Correct? Force exerted by M2 on M1. See, action, reaction. That will act on two different bodies. Then draw the free body diagram for M2. Just only free body diagram for M2. Only for M2. M2. Upward is how many forces? On M2. How many forces are acting? Yeah. Normal reaction force. Upward nothing but normal reaction. And one more is acting downwards. What is this? M2G. Clear? Then what is N2? N2G. Is it clear? N2 formula? Coming to the M1. On M1, N1 is up. Are you able to see everything clearly? N1 is up. And N2 is down. On where? On M1. Weight of the body? Downwards. Therefore, N1 balanced by what? M1G plus N2. So N1 balanced by M1G plus M2. What is N2? N2G. So what is N1? M1 plus M2 into G. Feel correctly, then only you will understand. For 2 blocks, nothing. 3 blocks, also nothing. Okay. This is possible if you are comfortable with the FBD concept. Okay. Normal reaction is the contact force. And if it acts upward on one body, downward it will act on another body. Okay. N1 on M1. N1 on ground. N2 on M2. N2 on this is M1 by M2. Finally, what is N1 I am getting now? N1, I am getting M1 plus M2G. N2, M2G. Will you try for 3 blocks? Don't feel as a complicated, it's nothing actually. Will you try for 3 blocks? For 1 block, nothing. 2 blocks, okay, I think you are feeling some inconvenience. What about 3 blocks? Will you draw the free body diagram for 3 blocks? Tell me, anyone?
Yes, sir.
Okay, you try in your free time. Right now, let me continue. Here I'll give you simple logic for this. How to remember the formula. Instead of drawing the free body diagram, let me see how to get direct formula. This is M1. This is M2, M3. If they given M4, you can write it. Here, one normal reaction, N1. Here, another normal reaction, N2. Here, N3. Very simple logic, very simple. This is N1, isn't it? N1 above, how many masses are there? N1 above, how many masses are there? N1 above, see my hand.
2
Above,
masses.
2 masses, M1 plus M2 into G, that's it. N2 above, how many masses are there? N2 above, only M2 is there, no? N2 above, only M2 is available. So, M2G. Similarly, N1 above, tell me, fast. How many masses are there above N1? 3. Shall I write directly? Finish. Answer. Nothing this is. Tell me, M2. N2 above. N2 above. What are the masses are there? M2 plus M3. N3. That's it. If you want to draw the free body diagram, here one N3 up, N3 on N2. Here one N2 up, N2 downward, N1. So that may feel some complicated, but this is the easiest way. N1 above, how many are there? If 10 masses are there, 10 coins are placed one over the other. If they ask you to find normal reaction at the bottom, 10 mg. If m is the each mass. If they ask you to find here, if above some 6 are present, 6 mg. Okay, like that. Now see, N1 above how many? 1, 2, 3. Add it. If this system move up with acceleration A upward, tell me how to get it now. For suppose this system placed in a lift. If the lift move up, then what is changes? G will be changes or
G
not?
plus A will become, sir.
Very good. In place of G, you write G plus A. If the same body system move down, wherever G is
Minus
there,
A.
that way you try to learn it. Okay. So G plus A, G minus A, along horizontal nothing, because we are discussing along horizontal only. Okay. If it move up, you replace with G as a G plus A. If it moves down, replace G as a G minus A. Very simple logic. Okay. No need to worry, because I'm teaching very basic level of questions only. Don't worry, everything will come slowly. Completed this one? Shall I go for the next topic?
Yes, sir.
Yeah. So write the next heading after this: angle of friction. Angle of friction. Okay, this is your interest free body diagram, and anyhow the way I shown here. Write down the heading: angle of friction.
So can you repeat, sir, what we should write?
And yeah, I'm writing on board. Angle of friction. Angle of friction. Simple thing. Angle of friction. We can represent it with something pi symbol. Angle of friction. Yeah. Let us see what is this angle of friction. To get this, let me consider a block which I am going to place on a horizontal surface. So a block which is placed on horizontal surface, whose mass is something m. Whose mass is m. Then we know normal reaction force is upward. If I apply any force in this direction, okay, if this force is some less force, minimum force, then is this block will move? If
No,
this
sir.
is
Yes,
more,
sir.
yeah, see, consider a block of mass m placed on a rough horizontal surface. Placed on rough horizontal surface. Rough means something new will be there. Okay. If this applied force is greater than the frictional force, then the block will move. If I apply a force right side, in which side the frictional force will act?
Opposite.
Opposite side.
Opposite.
Opposite.
Is that frictional force act on body or on floor?
On body.
Body.
On,
On body.
Confirm?
Sir, it will
Yes,
act
sir.
on both,
Yes,
sir.
sir. Confirm,
Sir,
sir.
it will
On
act
body.
on both.
Very good. It will act on body, floor right side. Okay, floor is right side, but generally in the books, how will they represent is? We don't think that is acting on floor back side. So general representation we will take like this. Okay, but this act is the bottom of the body. Got it? This frictional force act is the bottom of the body. On floor right side. On floor right side. Okay, leave it because floor is at rest with respect to the body. Now, if this is maximum value, then the body will move with acceleration. Okay. Here I applied a force so that the body does not move. If the body does not move, then this frictional force is reaches to maximum value. If the body is at rest, tell me what is the name of this friction?
Static friction.
Direct friction.
Static or otherwise limiting friction. What is the limiting friction? The maximum value of what is
Static friction.
limiting friction?
Maximum value of static friction.
Maximum value of static friction called it as limiting friction. Okay. Now let us suppose the body does not move, so that limiting friction will act. And these two forces will have some resultant. These two forces will have some resultant. That resultant is, let us suppose like this. Okay, this is what R. What is R? Resultant of frictional force and normal reaction. R is the resultant of frictional force and normal reaction. And this resultant makes something angle to the n. That angle, let me call it as pi. That angle is pi, and that pi call it as a angle of friction. Now let us see how to define that. So resultant makes an angle with what? N.
Normal reaction.
Resultant makes an angle with n is nothing but pi. Don't worry, I will give the definition. Okay. And this resultant is what? Resultant of how many forces? That R is the resultant of
Friction and normal.
what are the one is normal,
Another is
other one is
friction.
Static friction.
static friction. Okay, limiting friction or static friction. So, angle of friction is defined as the angle made by the. Are you reading? Angle of friction is defined as the angle made by the resultant of angle made by the resultant of normal reaction and frictional force, resultant of normal reaction and frictional force, normal reaction and frictional force with the normal reaction. Don't confuse. Normal reaction, frictional force with the normal reaction. Read the words, then you will understand
Can you
easily.
repeat, sir, the definition? The resultant of
Angle of friction is defined as the angle made by the resultant of, written up to here, angle made by the resultant of normal reaction and frictional force, resultant of normal reaction and frictional force with normal reaction, with normal reaction, written.
Repeat once more, sir.
Yeah, angle of friction is defined as the angle made by the resultant of, what is this resultant? Resultant of how many forces? Resultant of
Two forces.
normal reaction
Forces.
and frictional force,
normal reaction and friction.
with the normal reaction. Otherwise, in simple way, angle made by the resultant with normal reaction also called as angle of friction. But what I am using is resultant of, I use two words again, that's why you are confusing, nothing to worry. Angle made by the resultant with normal reaction called as angle made by the resultant with normal reaction call it as angle of friction. Okay. Now from the diagram, we can write tan pi. Tan pi, tell me now, tan pi. Y-axis by x-axis. For this one,
Fs
opposite
plus
is Fs. Yeah, Fs otherwise Fl by N. What is Fs?
static.
Mu S by N. N gets cancelled. Tan pi is what? Tan pi. Are you able to see this one? Tan pi it is equal to mu S. So I
Yes,
want,
sir.
yeah. What is pi? Pi is equal to tan inverse of mu S. So this is the equation for what? Angle of friction. Simple equations.
Sir, how Fs is equal to nu S by into N?
Mu S. Tell me.
Sir, is that a formula that Fs is equal to nu S by into N?
Yesterday you attend the class. Fs is equal to mu Sn. Fk is equal to mu Kn. Fr is equal to mu Rn. Otherwise, F is equal to mu N. That's it. Okay. If it is static, you write S. If it is kinetic, you write K. If it is
Okay,
rolling,
sir.
if it is rolling, you write R. So tan inverse of mu suffix S. Otherwise, you write mu. That's it. That S will give the meaning because static won't write no. And see from the diagram, we can write one more step. From figure, we can write resultant force. This resultant force, shall I write it as n square plus fs square? What is resultant? N square plus fs square. Hypotenuse. Okay. Use the Pythagoras theorem. R square is equals to n square plus fs square. R is equal to root of n square plus fs square. What is fs? R is equals to
Nu
n
S.
square mu s n whole
Nu
square. Okay. Then what is R? If I take n outside, correct? What is mu? Mu s. Okay, this is one formula. N is equals to n. One place. Shall I write tan square pi? Mu s is how much? Just now got it formula. Tan square pi. One place tan square theta. Second
Tan
theta.
square 5.
Second square and root is there. Second
Root
theta.
of
Yeah. R is equals to n secant theta. What
secant
is
pi.
n? Yeah, what is n? N is balanced by mg. Shall I write n as mg? Shall I write this n as a mg?
Yes, sir.
Mg. Second theta as a, shall I write second pi as a cos pi? So what is the resultant force in other form? Mg by cos pi. If mass is given something 1 kg, pi is given something 30 degrees, is it possible to find the resultant force or not? For suppose mass is given 1 kg, mass is given 1 kg, angle of friction mentioned as something 30 degrees, then what is the resultant force? R is equals to 1
20 by
into,
root 3.
yeah, g by cos 30, 2g by root 3. Because cos 30 is root 3 by 2, 2g by root 3. Now let us see some conceptual formulas. Next I'll continue 2 to 3 different problems today. Completed up to now? Is it over? Shall I go for the next concept?
Just a second.
Just a second, okay,
Last
carry on.
one.
Yeah, okay, carry on, carry on. So keep next formula as a something note. Whenever I get something note, that is useful. Formulas are useful to solve some basic problems and good level of questions also.
Done, sir.
So better you mention something known as a distance, stopping distance. Yeah, before that, let me find, before this stopping distance, do one thing. Write down, I'll find stopping distance later. Before that, you write it. Acceleration of a body. Write down the heading. Write down the heading. Next, I will find stopping distance because we need acceleration. That's why let us find first acceleration. Write down the heading. Acceleration of a body moving on rough horizontal surface. Acceleration of a body. Acceleration of a body. Acceleration of a body moving on rough horizontal surface. Rough
Moving on.
acceleration of a body moving on a rough horizontal surface. Written the heading. Acceleration of a body which is moving on a rough horizontal surface. Rough horizontal surface. So let us suppose this is the rough horizontal surface having coefficient of friction mu. If the body moves, you can write mu k. If the body rolls, you can write mu r. If it is at rest, mu s. Let us suppose the body moves. When it moves, if the applied force, okay, F applied, which is equal to something F, and what is acting left side? F. When it moves, tell me if F applied is greater than, if F applied is greater than
FK.
F. Fk.
FS.
Fk, because it is moving. Okay, that's why written frictional force. When it is at rest, you think that is Fs. If it is in motion, no need to mention downside. Fk, that's it. Okay, that's why every time I am writing F, that's it. If F applied is greater than frictional force, then body will move or not?
It will move, sir.
Yeah, it will move with certain acceleration A. It will move with certain acceleration A. Then it will move with certain acceleration A. Then Fr, you know how to draw the free body diagram. Fr, net force is what? Net force is F minus F. Because this is dominating, F minus F. If it is moving, you can write Fk. What is Fr?
Result force.
M A, net force, M A F. This is mu K N. Mu K N. So what is N?
MG.
Yeah, mg. Okay, so ma is equals to F minus mu suffix k mg. Take this m right side. F by m minus mu kg by mu k mg by m. M cancel. Correct? Is it equation is this one is correct or not? A is equal to F by m minus mu kg. So this is what acceleration of a body which is moving on rough horizontal surface. Okay. F by m minus mu kg. If applied force is not there, tell me with what acceleration the body will move? Minus mu kg. If F is not available, just we can write A as a mu g. Okay. If rough surface is there, then the body moves with an acceleration A, that A which is equivalent to mu kg. Okay. In a previous chapter, you learned in a straight line motion. If a body starts with initial velocity u, after traveling distance s, it will come to rest. Then tell me which formula you are using in kinematics. Remember kinematics. A body starts with u speed, after traveling a distance s, it will come to rest. Then what is the distance? To
S
find
equals to plus half
yeah.
AT square.
No.
V square minus U square is equal to 2AS.
it. That's it. V square minus U square is equal to 2AS. In that A, we written as it is A. But in A, here we are going to write mu G. Let us see how I am going to extend that also. First, you take this. I'll continue one concept. This is the acceleration of a body moving on a rough horizontal surface. Let us see one more formula which is useful to solve some basic level of problems. Stopping distance. Yeah. Let me find the, yeah. Until say a block of mass m starts with an initial velocity u. Okay, block of mass m starts with an initial velocity u, and after traveling a distance of s, the block comes to rest. The block comes to rest means what is v? The block comes to rest means what is v? V becomes 0. V becomes 0. And see, mu is the coefficient of friction between the block and surface. Mu is the coefficient of friction between the block and surface. To find this stopping distance, generally we have to use a work concept. But right now, we don't know the proper meaning of the work, means that is there in the next chapter. So we use work and energy theorem, but that will come in the next chapter. So that's why I am going to use our known formula. What is our known formula is? Our known formula is V square minus U square is equal to 2AS. So V square minus U square 2AS. Tell me, is that A is acceleration or retardation?
Retardation.
Retardation.
It will comes to rest retardation. What is V? 0 minus U square. This A is nothing but mu G. Here A nothing but mu G, because there is no applied force here. Just you take this as 0 something here. If it is 0, what is A? Mu kg. Shall I write A as minus mu G? Minus mu G. If there is no applied force, A as minus mu G. Otherwise, F nothing but what? Regular formula. F is equal to mu N. F nothing but, this is nothing but a F, because applied force is not there. That is balanced by, the frictional force is balanced by MA. Because there is no applied force. Okay. I think you know, maybe in static friction, applied force proportional to static friction or not? Remember yesterday topic? Yeah, yes. If I apply 12 Newton of force, what is the static friction in between the block and surface? 12 Newton?
12 only, sir.
Yeah, 12 only. That's why that F nothing but MA also. Small f is equal to capital F. Capital F nothing but MA. So F nothing but MA. So mu, this is mg. M cancelled. A is equal to what? Mu g. A is equal to, general formula in friction here is A is mu g. Okay. If two coefficient of frictions are given, mu s, mu k, both are given, tell me what is A? Right now, if only one mu is given, A is equal to mu g. First body starts from rest. Means whenever the body is at rest, mu nothing but mu s. Follow my words. Mu nothing but mu s when the body is at rest. If the body moves, then mu converted into what? Mu k.
Kinetic friction.
Yeah. Is that both frictions are same? No. Then you can go for the difference. Mu s minus mu k into g equivalent to A. Okay, you keep in mind, A is equals to, if two frictions are given, you can write mu s minus mu k into g. Mu s minus mu k into g as A, acceleration. Right now, what is this? Mu g into s. Then what is s? S is equal to minus u square by 2 mu g. Minus nothing but, that is a that body comes to rest. Okay. Otherwise, you can write A as a minus, then minus both sides will be cancelled. So before coming to rest, the body covers this much of displacement. U square by 2 mu g. You take the magnitude. Okay, minus nothing but the body undergoes retardation. U square by 2 mu g. This is mu, it's not a u. U square by 2 mu g.
Sir, explain once more, sir.
Which one? See, b square is 0 now.
Yes, sir.
U square has this.
Yes, sir.
A I written with mu g. A I written as a mu g. Okay, you are feeling A as retardation?
Yes, sir.
Are you feeling A as retardation? Then you can write A as what? Is it okay?
Yes, sir.
Is it okay? Then shall I cancel minus on both sides?
Yes, sir.
Then what is the answer now? U square by 2 mu g, is it correct or not?
Correct, sir.
Then go for it. And see, we can find the time also. After what time the body will comes to rest? After what time? Tell me to find the time. Which equation is convenient?
V is equal to U plus AT.
That's it. Yeah, if they ask you to find the time, okay. V is equal to U plus 80. V becomes 0. U becomes U. A nothing but minus mu g. Why I am writing A as minus mu g? Tell me. Retardation. Got it? Okay, earlier I forgot to write, but that's correct actually. Okay, no problem. Minus mu g. A is nothing but minus mu g into t. Then what is U? U is equal to minus mu g t. What is t? U by
G.
mu g. Okay, be careful with writing U and mu. Is it clearly visible? U and mu. Is it visible? U
Yes.
and, yeah, is it okay? U by mu g. This is the time. So you remember this formula to find some questions. A body starts with something 2 meter per second. After traveling a distance of some 5 meter, it will comes to rest. Then at what time it will comes to rest? After what time interval the body comes to rest? Okay. So try to solve those type of questions. Otherwise, you start one simple problem. Add some simple problem. Write down. A body starts with 2 meter per second. A body starts with 2 meter per second. 2 meter per second. And after 2 meter per second. And finally, after traveling some distance, it will comes to rest. After traveling some distance, it will comes to rest. After traveling some distance, it will comes to rest. A body starts with 2 meter per second. And after traveling some distance, it will comes to rest because of coefficient of friction between block and surface is 0.5. Coefficient of friction between block and surface is 0.5. Okay, 0.5. Mu is given 0.5. Because of that, it comes to rest actually. 0.5. Then find distance covered by the body before coming to rest and time taken by it. Find, simple question, general things. Find distance covered by the body before coming to rest and also find time taken. Find distance covered by the body before coming to rest and also time taken. Time taken. Simple question. Time
2
taken.
by 5.
Yeah, S is equal to U square by 2 mu G. G you can take it as 10. U square 4. 2 into, this is 0.5 into 10. Okay, so 4 by 10 this is. How much it is now? 0.4. 0.5 means 1 by 2, 2 to cancel. 10, 4 by 10, 0.4. Got the 0.4? Check the calculations. Simple things, because I given easy numbers. Got 0.4 everyone? Figure? Anyone?
2 seconds.
Yeah, time is how much? 4.5 into 10.
Sir, 2. Sir, 2, sir. Not
2
4.
seconds. 2 seconds.
Sorry, U is 2 now? Okay, okay. 2. Tell me how much it is now?
2 seconds.
Finally?
0.4 seconds.
0.4
seconds.
See, this is 2 by 5. Point. Yeah, what does in 0.4 second it will cover 0.4 meter, no problem. First problem itself is same. It covers 0.4 meter and at what time interval it is going to reach 0.4 meter?
0.5
Okay, first
seconds.
we got the same numbers, no problem. Because I'm giving some general numbers. Like this, you how to solve the problem, okay? Because problems are so many. If you open some different books, definitely you will find new numericals. Numericals are so many. The way you try to understand how I'm extending the problem. Right now, I given some 3-4 lines words. No need of actually giving all the words. By observing the diagram, you try to understand what they given and what you have to find. Okay. Let us see one more question. Let me give one more problem. Ready? Ready for the next problem?
Yes,
Shall I
sir.
give?
Yes,
Shall I
sir.
give? Add it. A body moves with an acceleration of 4 meter per second square. A body moves with an acceleration of 4 meter per second square. 4 meter per second square under the application of force F. Repeat again. A body moves with an acceleration of 4 meter per second square under the application of force F. If force is doubled, then it moves with an acceleration of, if force is doubled, then it moves with an acceleration of 6 meter per second square. Don't think that 8, 6 meter per second square. If force is doubled, then it will move with an acceleration of 6 meter per second square. 6 meter per second square. Find coefficient of friction between the body and the surface. Find the coefficient of friction between the body and surface. Find the coefficient of friction between the body and surface. See, the body is moving on surface, having some acceleration. Then tell me which one you are going to use to find this problem. And this is also the basic problem. See, under the application of force F, it moves with an acceleration of 2 meter per second square. Okay, mu is the coefficient of friction. Under the application of force double means 2F, it moves with an acceleration of, how much I given? First one, how much? First
The
one,
first
4.
one.
First one, 4. Okay, no problem. Yeah.
Sir, minus
Yeah.
0.2, sir.
Yeah.
Sir, minus 0.2.
Minus, how minus is possible? Coefficient of friction is always positive. Coefficient of friction is always positive. We cannot get negative answers. The value lies in between 0 and 1. It cannot be a negative. Coefficient of friction is ratio. Okay. Negative means
Sir,
that is
0.2.
0.2. Maybe. Let us see. See, for the first case, we have a formula already. F by m minus mu g, mu kg or mu g. That's not a problem. You can write mu k. Mu k means when the body is in motion. Okay. What is A1 for the first equation? A1. A1 shall I write 4? 4 is equals to F by m mu g or mu kg. That's not a problem. This is equation number 1. And the second one, tell me. 6 is equal to?
2f by m minus mu.
Right. Yeah. Solve these two equations so that you will means f will be cancelled out. You will get mu. They are asking to find mu only. Solve the two equations.
Sir, we will get minus 0.2 only, sir.
Minus, how it is possible? Tell me. Minus only you are getting.
Yes, sir.
Minus. Let me check. Okay, I don't know. Because I given some regular numbers now. Let me check. So multiply equation 1 with 2. I am solving with the second equation. Let me multiply equation 1 with 2. 8. Multiply equation 1 with 2 and 8 is equals to 2f by m minus 2 mu g. Is equation 1 is correct? Because I multiplied 2 on both sides. Check it once. Is it correct? Pick out anyone.
Correct, sir.
Yes, sir, correct.
Solve with 2f by m mu g. If I got negative means the given data itself is wrong. No need to worry. Okay, because mu cannot be negative. That's it. And subtract. How much this one? 2. Okay. Yeah, we are getting
Yes, sir.
negative. We are getting negative. 2. That is minus mu g. Yeah, you are getting negative. Then we will do one thing. First one, you just take 2 because for 4 many number you are getting negative means not possible. Given data is insufficient, no need to worry. In place of first one, how much I given 4? Can you change it as a 2? Let us check it. No problem, no need to worry. You try to enjoy the problems like this. Means you feel the problem. You got negative means the given data is wrong. When it is getting clear means mu cannot be a negative. Okay. So better you change the data. Let us see whether it is positive or negative. Here I am changing to. Can you change it? Change it already?
Sir, we will get 0, I think. No, sir,
Yeah.
no.
No. Let us verify it. Because mu cannot be negative. That is clear.
Yes,
So
sir, positive only, sir.
if we got negative means data is insufficient. No need to worry. Because I am giving some regular numbers. Okay. So tell me how much it is? Minus 2. Minus 2, this is how much? Minus mu g. Minus on both sides cancelled out. Correct?
Yes, sir.
So mu is equal to 2 by g. 2 by 10. Fine. Okay, no need to worry once you got the negative. Negative means you try to understand why it is wrong. Because mu cannot be a negative. Maybe first one moves with less acceleration. Otherwise, second one moves with more acceleration. Because I given regular general numbers. You try to understand what I given. First one may move with less acceleration. Otherwise, second one may move with more acceleration. Then only you will get some positive answers. If you got negative means the given data is not clear. Okay, so we got this mu. Shall I continue one more problem or enough? Shall I try one more?
Yes, sir.
Okay, then write it now. Find mu as shown in figure. Because you are writing number of words now, let us avoid it. Find mu as shown in figure. Find mu. If you want stories means I can add the stories, but no need. Find mu. This is 6 kg, 4 kg. Find mu. See, there will be a mu here. If you want story means I can give the story. 4 kg block is placed on rough horizontal surface connected to the wire. Other end of the wire connected to the 6 kg block hanging vertically downwards. And other end of the wire is connected here with an angle something 30 degrees. Then find the coefficient of friction between the block and surface. Instead of writing all these words, just write even simple. Find mu. Where mu is possible? Only here only mu is possible. Here there is no possible because this is not touches the surface. If it touches, mu here also possible. So right now let us find mu here. One way you find it. This is 4 kg. Is it visible 4 kg? Otherwise you listen my words. 4 kg. This is 4 kg. 6 kg. And this is 30 degrees. 30. Are you able to see this 30?
Sir, body has acceleration, sir.
Yeah.
Sir, body is at rest or has acceleration, sir.
I didn't follow. Can you once again?
Sir, body is at rest or it has some acceleration, sir.
It is now starting. It is at rest. Okay, because of this body, it will move. It will move. Because of this body, it will move with an acceleration A. So at equilibrium, the body is like this. This is the case when the bodies are in equilibrium. Whenever the bodies are in equilibrium, what is this now? Tension, huh? Can I resolve the tension into two components? Shall I resolve the tension into two components?
Yes,
Above one
sir.
is what?
Yes, sir.
This is T cos 30. And what is this component?
P sin 30.
Times sin 30. T cos 30 balanced by 6 kg. 6 kg nothing but 6g. 60. Weight of the 6 kg act vertically downward. 6g nothing but what? Got it this one? T cos 30 balanced by 60 Newton. Tell me, T sin 30 balanced by what at equilibrium position? T sin 30 balanced by T sin 30 balanced by
Fs.
what is it? Yeah, frictional force. So let me write T sin 30 balanced by F. T cos 30 balanced by 60. Shall I divide these two? 1, 2. If I divide equation 1 and 2, dt cancel sin 30 by cos 30. Okay, let's write sin 30 by cos 30, no problem. Sin 30, cos 30. F, what is F? What is F? What is F? Mu n followed. Sin 30, 1 by 2. This is root 3 by 2. Mu target. N nothing but mgr. N is nothing but 40. N 4 into G 40 by 60. Then 1 by root 3 mu 2 by 3. Mu is equals to 3 by 2 root 3. Check the calculations. Check the calculation, everyone.
Sir, root 3 by 2.
Root 3
By 2.
root 3 by 2. Check the calculations. Verify the calculations. Root 3 by 2.
Sir, root 3 by 2, sir.
It's not root 2.
Root,
Huh?
root 3 by 2.
Okay. If they ask you to find tension, is it possible to get the tension in the string? Yeah.
Yes, sir.
Using this T sin 30 is equal to F. T into 1 by 2 is equal to mu n. Mu, just now we got it. Tell me, can anyone will give the tension? If they ask you to find the tension, let us see how much.
20 root 3.
Very good. 20 root 3.
20 root 3.
Shall I write steps on board or no need? 20 root 3. Just you write T into 1 by 2 is equal to mu into 40. Mu already I got root 3 by 2. Substitute root 3 by 2. Root 3 by 2 into 40. 1 by 2 cancel that. 40 root 3 I am getting.
Sir, 40 root 3.
Someone telling 20 root 3? Check it. Is
40
it 20 root 3 or 40 root 3?
Yes, sir, 40 root 3.
Yeah, it's 40 root 3. Verify once. Because T into
Yes, sir, 40 root 3, sir.
T into 1 by 2 which is equivalent to mu into 40. Mu I got root 3 by 2. Left side sin 31 by 2. 1 by 2 to 2. Left side 1 by 2, right side 1 by 2 cancelled. 40 root 3. Verify once. Correct? Huh?
Yes, sir. 40 root 3.
Yes, sir,
Okay.
40 root 3.
Okay, let me stop now. Tomorrow let me cover the concepts.
Sir, bodies are at rest now, sir, here.
Yeah, right now at rest because at equilibrium. Equilibrium means at certain instant of time they are asking. If it is in motion, again you have to get acceleration and all the stories. See, what is there this one?
Sir, it will not accelerate in future further also, no, sir.
Yeah, it will not accelerate.
Thank
See,
you.
okay. Let me stop now today. Thank you.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir.